Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through how to work each of the problems on the Chapter 8 Circles quiz review. And my disclaimer is always, I need you guys to work these problems on your own and then come to the video and figure out where you got stuck or figure out any mistakes that you might have made. For my Clemson reference, this is all I got for you guys today. Here's my orange electronic whistle that I use in class. That's all I got. So this is going to be a pretty long video. Guys, circles is hard. It's just hard. I've been telling you guys the whole unit that the main reason why is you got so many different concepts and formulas and relationships that you got to remember. I've been telling all my classes that, in my honest, humble opinion, if you guys spend less than an hour studying for this quiz or for the test, then that's just not going to cut it. It's going to be an uphill climb for you. You're going to have to work your rear end off to really study your graphic organizer, make flashcards, whatever you got to do to make sure that you, when you walk into the classroom, that you know what an inscribed angle is, that you know the exterior is 1/2 of big minus little. You've got to know that stuff. You can't waste time on the quiz and the test trying to go back and figure out, oh my goodness, I can't remember which formula this is. You just don't have time for that. These problems are too complicated. Okay, so please study relationships and have those down pat before you walk into your classroom. All right, so let's jump right in here. So in these first 4 problems here, it says find the measure of the arc or the central angle indicated. Assume that lines that appear to be diameters are actual diameters. I would also strongly encourage you guys, please go grab you some crayons from your little brother or sister. Get some colored pencils, some markers, whatever, because I'm the geometry teacher and I've been doing this for years and I still use colored pens and pencils to make sure that you're highlighting what you need so your brain focuses on what we're actually looking for. Okay, so let's zoom in just a little bit here. Okay, alright, so in this first one they are asking for the measure of arc. There's a little arc right there, so we're looking for an arc, not an angle. The arc WS. Okay, so let's color code that. Maybe I'll do my arcs in red. We want WS. Okay, so let's color that real quick. Your brain just says, okay, I got it. I'm looking for the red arc. Now, how do I use the other pieces of information in the diagram to help me figure that out? Well, just like we have vertical angles, we kind of have vertical arcs. If this arc is 65, then this arc across from it is also 65. Because if this arc is 65, then that central angle is 65, which means that vertical angle is 65, which means that this opposite arc is also 65. Okay, so now that I have the blue piece, I've got the red piece plus the blue piece. Guys, in these problems, if you get stuck and you don't know what to do, always remember that you've got 180 degrees and 360 degrees in your back pocket in your mathematical toolbox. Okay, so how do I get this red piece? Well, the red plus the blue form what? They form a 180-degree semicircle. Okay, so I'm not going to do this in every problem, but just for this first one, just so you guys can see it, if I just kind of go around the outside, the whole green arc is a semicircle. So all I have to do to find the red arc is take the green arc, which is 180, minus the blue arc, which is 65, and that gives me the red arc, which in this case is 115 degrees. Okay, so that's not so bad. All right, number 2. Find the measure of HD. Okay, HD. Where's HD? Okay, got it. This bad boy right here. Okay, I need that red arc. How do I get the red arc? Okay, well, it's kind of similar. If I had the blue arc, if I had the blue piece, then I could just subtract the 180, subtract the blue piece from 180 to get the red piece. Well, in this case, I don't have the blue piece. Well, how can I find the blue piece? Well, once again, let's look at our diameter. That's a diameter, which means I definitely have a semicircle. If you don't have a diameter, guys, you're not going to be able to use 180 degrees. I've got to see that diameter going through the middle. So the green arc is 180. So to find just this little blue piece, can I do 180 minus 70 minus 69 because this is a semicircle? So I'll do 180 minus that guy, 70, minus that guy, 69, and that gives me 41. Okay, so the blue piece, the blue arc, is 41 degrees. Now I could also use 180 again to find the red piece. So I'll do 180 minus 41, and that gives me 139 degrees for the red arc, which is HD. Okay, number 3 is about as easy as it gets. Find the measure of TQ. Okay, TQ. Okay, got it. Red arc. How do I find that? Well, if this central angle is 85, remember central angle is equal to the arc. That means this guy is 85. And so to find the red arc, all I need to do is add the 85 plus the 65. So that's going to be 65 plus 85. That's going to be 150 degrees. Okay, moving on to the next one. All right, now they want to angle SQU. Okay, SQU. And guys, there are multiple ways to do these problems. You can get the same answer doing it a different way than I do it here on the video. It's the beauty of mathematics. All right, so to get that angle, I need the snow cone. I need the red arc. I don't have the red arc. I got this piece, 58, because the central angle is 58. These two guys are 58. I need this piece up here. Well, once again, we got 180 degrees in our mathematical toolbox. Okay, so this green arc is 180 degrees. Okay, well, how do I get this piece? If I had VU, then I could subtract VU and 58 from 180, and that would give me the other piece. Well, I also have another semicircle right here. Okay, this guy is 100, so that means VU is 180 minus 100. 180 minus 100 gives me 80. So that means that, I'll do this in green, that means that VU has to be 80 degrees. Okay, so now I have this green semicircle. Okay, so to find ST, I just do 180 minus 80 minus 58. Minus 80 minus 58, and that gives me 42. Okay, so I'll put this little piece up here. This is 42. Okay, so now to get the whole red piece, my original arc that I want, I need to add those two guys together. So 42 plus 58 gives me exactly 100 degrees. I wonder if anybody can see if there's a different way to do this. I purposefully did this the long way. Does anybody have a light bulb that goes off? Look at what we have here. 100 degrees over here. 100 degrees over here. These two guys are the same. This is a red arc. That's the same thing as this guy. Okay, so I did that on purpose so that you guys could see a lot of times you can save yourself a lot of time by finding the shortcut. Okay, if this is 100 degrees, that means this guy has to be 100 degrees, which means this central angle has to be 100 degrees, which means this arc has to be 100 degrees. Okay, so always look to see, can you find a shortcut on how to do this. Okay, get my camera back in focus here. There we go. Okay. Alright, so number 5. Now we're on to the chords and the segments. Okay, we got to remember one of our relationships and concepts said that if you got a chord that makes a 90-degree angle with the radius, then the chord is bisected. Okay, so that means this piece of the chord and that piece of the chord are the exact same. We are cutting this purple chord in half, and the only reason I know that is because there's a right angle there with the radius. Okay, so if that piece is 8.7, that means this piece is 8.7. Okay, and so now we have good old-fashioned Pythagorean theorem. We've got a squared plus b squared equals c squared. We're trying to find x, the hypotenuse of our triangle, which in this case is also the radius. Okay, now I don't know how you guys were taught Pythagorean theorem. To me, there are only two concepts. There are only two potential scenarios. Either you're trying to find the hypotenuse or you're trying to find the leg. If you're trying to find the hypotenuse, then it's just a squared plus b squared equals c squared. You're going to square both of these numbers, add them together, and then take the square root. If you're trying to find the leg, if the variable's on the leg, you're going to square both numbers, but instead of adding them, you're going to subtract them and then take the square root. So in this case, I'm trying to find the hypotenuse, so I'm going to square both numbers. 4.6 squared plus 8.7 squared, and that gives me, that'll be x squared. 4.6 squared plus 8.7 squared is 96.85. And then I'm going to take the square root of that number. So x ends up being 9.8. And yes, that makes sense because that's the longest side. It's bigger than 8.7. All right, number 6. Okay, we're trying to find this piece. Okay, trying to find that little piece. So once again, I'm thinking Pythagorean theorem. Well, if this is another chord that's being bisected because it forms a 90-degree angle. So if this piece is 8.4, this piece is 8.4. But now I'm trying to find a leg. Okay, so instead of squaring these two and add them, I'm going to square them and subtract them. So x squared is going to be equal to the big one squared, 9.9 squared, minus the little one's, oops, you can't see that, minus the little one squared. Okay, hypotenuse squared minus the leg squared. So x squared is going to be equal to 27.45. Take the square root, and x is equal to 5.2. If you guys want to set up your equation the correct way with a squared plus b squared equals c squared, you're more than welcome to do that. Okay, you can do a squared plus b squared equals c squared. Okay, but watch what happens. I have to move this to the other side. X squared equals 9.9 squared minus 8.4 squared, and you end up right where we are here. Okay, I just skipped a step. Okay, so to me it's just easier to remember. Find the hypotenuse, square them, add them, take the square root. Find the leg, square them, subtract them, take the square root. That's just me. Just easier for me personally. Okay, number 7, tricky. Guys, you've got to know the difference between where that number is located. That number 22.2 is right in the middle. So that is the full diameter. If the 22.2 were over here, then that would be the radius, but that's not the case, okay? So that's the diameter, so we got to cut that in half to find the radius, which is 11.1. All right, so we do have Pythagorean theorem. Chords being bisected. Okay, so we got the 8.5 and we got the 11.1. I need to find this little piece here that I'll do in green. Okay, we're trying to find x, so I can't call that x, so let's call that something else. Let's call it y. And let's do Pythagorean theorem to find y. We're trying to find a leg, so we're going to square and subtract. So I'm going to say that y squared is going to be it's always the big one, always the hypotenuse squared, 11.1 squared minus the other leg, 8.5 squared. So y squared becomes 50.96. Take the square root, and y is 7.1. Okay, so we can put 7.1. So now the question is, how do I get the red piece? How do I get x? Well, let's do this in blue. What do you call that line? That's the radius. What do you call this blue line? Guess what? That's the radius. So this blue line is also 11.1. So to find the red piece, I just need to do the whole radius, 11.1, minus the green piece, 7.1, and that will give me the little red piece. Okay, so x is going to be the radius, 11.1, minus what we found using Pythagorean theorem, and so the little piece is simply 4. Remember, guys, the chord is being bisected. The radius is not being bisected. That's a mistake I see. A lot of students say, oh, that's 7.1. Well, guess what? That's got to be 7.1. No, that's not the case. Only the chord is cut in half. Okay, tricky again. Well, we've got a chord that makes a 90-degree angle, so the chord's bisected. So if that piece is 8.6, and this piece is 8.6, well, we've been using Pythagorean theorem the whole time. I don't see a right triangle anywhere. So how am I going to be able to use Pythagorean theorem? Well, let's make a triangle, guys. Let's make one. Connect that piece right there, and we have just formed a right triangle. This guy is a radius, 9.5. So what do we call this? This is also the radius. So this is also 9.5. Okay, so now once again we're going to have to do the same kind of thing we did on the previous problem. We got to find the green piece first. I'll call that y. Alright, so we're trying to find a leg, so we're going to square these numbers and subtract them. So y squared is equal to the big number squared, 9.5 squared, minus the little leg, 8.6 squared. So y squared ends up being 16.29. Take the square root of that, and y ends up being 4. Okay, so y equals 4, and once again, to find the red piece, we're going to take this whole length, which is just a diameter, it's just that guy right there, and we're going to subtract. So x is going to be equal to the whole radius, which is 9.5, minus the 4 that we just found. So x is going to be 5.5. Okay. Alright, let's move along. A lot of stuff, guys. I know, it's just tough. Companies want to know if you can do this. If you can do this stuff, then they want to hire you, because this is not easy. Okay. Alright, number 9. Okay, notice in all 6 of these problems, 9 through 14, guys, you got to remember this. With all these different angles, interior angle, exterior angle, central angle, what did I say in class? What's the most important thing? The location of the vertex. Okay, notice we only have one number here. Notice where the vertex is. Vertex on the circle. 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 Okay. Alright, so when the vertex is on the circle, that is an inscribed angle. You must be comfortable with that when you walk into the quiz. And you've got to know the inscribed angle is 1/2 of the intercepted arc. You just got to know that. Okay. So I'm looking at this first problem, and here's where, again, I'm going to highlight what they want. Here's the question mark. Okay, so they want this red arc. How do I get the red arc? Okay, there's only one number in this whole problem, 34, so obviously we have to use that. So the 34 represents this angle right here that I'll do in blue. Okay, so there's my blue angle, and that's going to intercept which arc? Think of the snow cone, guys. You got to find the snow cone. Okay, if I turn this upside down, there's my snow cone. The blue is the cone, and the green is the intercepted arc. There's the ice cream. Okay, got to look for the cone. Okay, so if we say that the inscribed angle is 1/2 of the arc, that means this guy right here, 34, has to be 1/2 of the green arc. Okay, so if 34 is 1/2 of this, do I multiply by 2 or divide by 2? I've got to multiply by 2. So 34 times 2 gives me 68 degrees. Okay. 34 is 1/2 of the arc, 1/2 of 68. Okay, so I'll just write up here 34 times 2 equals 68. Okay, alright, so how does that help me? Well, I've got the green piece and I've got the red piece. How do I find the red piece? When I'm stuck, what do you remember? 180 and 360. Okay, this whole arc, the green piece plus the red piece equals 180. So I'm simply going to do 180 minus this piece, the green piece, 68 equals, in this case, we get 112. 112 degrees. Okay. Alright, so that one's not so bad. I'm going to skip number 10, guys. That one is really tough. I'm going to come back to that one, do that one last. Let's move on to number 11. Where's the vertex? On the circle. Okay, that question mark represents this angle. Okay, so I'm drawing that in blue. Alright, so the intercepted arc, I'll do this in red. Here's the snow cone. This was pretty easy. Okay, there's my snow cone. Alright, so if I had the red piece, then I could just cut it in half to find the angle. Well, how do I get the red piece? When you don't know what to do, 180, 360. The whole circle equals 360. So can't I just subtract these two numbers from 360 and get the red piece? Yes, Mr. Bernice, I can do that. 360 minus 66 minus the 120. And that gives me 174. Okay, so the red arc is 174 degrees. All right, all three of these numbers add up to 360. And now to get the blue angle, I simply cut that in half. So I'll just say the measure of angle QSR is equal to 1/2 of 174, and that gives us 87 degrees. 87 degrees. Okay. I'll put this back up here. 112 degrees for our answer. Okay, let's move along to number 12. This was also pretty easy. Pretty much the same thing, actually. Just want to make sure you guys can do it. There's my blue angle. Here's the intercepted arc. There's my snow cone. So once again, this is basically the exact same problem. I just need to subtract these two numbers from 360. 360 minus 90 minus 72 gives me 198. So my angle, I'll say angle CDB is equal to 1/2 of 198, and that gives me 99 degrees. So this guy is 99, oops, sorry, do that in blue. This guy is 99 degrees. The red arc we said was 198 degrees. Okay, let's keep going. Number 13. Where's the vertex? On the circle. The only number I see is a 54. That represents an angle. If you're not sure, guys, what the number represents, please ask your teacher. Okay, so 54 is the angle. Once again, I've got my snow cone. The snow cone intercepts this arc in red. Okay, so inscribed angle is half of the arc. This guy is half of the red, so that means I got to multiply by 2. 2 times 54 is 108. So I'll put 108 right there. Okay, but what do they want? They want the green piece. They want the question mark. Okay, how do I get the green piece? I don't see any other numbers. When you get stuck, what do you think about? 180, 360, okay? The green piece plus the red piece equals this whole semicircle. We have a diameter. That's another clue. When you have a diameter, that should be red flag. Hey, maybe I might use 180. Maybe not, but I might use 180 in this problem, okay? So I can just simply do 180 minus the 108, and that will give me the green piece. So 180 minus 108 gives me 72 degrees. The green arc is 72 degrees. Check it. 72 plus 108. Make sure it adds back up to 180. Draw that in green so everybody sees we got a semicircle there. Okay, number 14. Okay, let's highlight what they want. We'll stick with green for the question mark. Okay, how do I get the green arc? Well, I've got two numbers here. Okay, well, let's start with, I don't think I can really do too much with the 63 degree arc here. So I've got the 91. Where's the vertex? It's on the circle. So this is another inscribed angle. So here's the snow cone. And then here's the ice cream for the snow cone. Okay, snow cone. So this is an inscribed angle. This guy is half of this guy. Okay, so I simply do 91 times 2. That gives me 182. So the red arc is 182. Okay, so now, how does that help me with the green arc? Well, I've got 182. I've got this 63, and 63 is an orange. So what can I do? What about if I added 182 and 63? That would give me the orange and the red. Well, the green piece would just add up to 360. So why not just do 360 minus the 63 minus the 182 that we just found, and that will give me 115 degrees. So this green piece would be 115 degrees. Check it, add them back up. Add 115 plus 82 and plus 63 and make sure they add back up to 360. Use common sense. Okay, are y'all ready to tackle this one? Yikes. Not very easy. I love it though. I love these kinds of problems. Okay, we are trying to find question mark. Okay, where's the vertex? On the circle. Okay, so let's do this in blue. Okay, so that's an inscribed angle. That means that is half of the snow cone. Here's the snow cone. Here's the ice cream. So if I found the red arc, then I would just divide by 2 to get the angle. Okay, so that means I'm going to need to find XW somehow. I'm going to need to find, I'll put this in, I'll do this in black actually. I'm going to need several colors for this one. I need XW, the black arc. Because if I had XW, I could add that to TX, and that would give me the whole red snow cone, and then I can divide by 2. Well, how do I get the little black piece? Well, let me think about this. I've got a 90, I've got a 78. It doesn't really help me. Well, I got this 97 here, so I probably can do something with that. I'll do this in purple. Stay with me, guys. You can do it. Here is another inscribed angle that I'll do in purple. Okay, that is going to intercept the purple snow cone. Okay, this is purple snow cone. Okay, so if the purple angle is 97 and that is half of the purple snow cone, I can multiply 97 times 2. Okay, 97 times 2 is equal to 194. Okay, so purple, the whole purple thing is 194. Okay, alright, so now what can I do with that number? Well, that will allow me to get the black piece, won't it? Because I've got the whole purple piece. I have this green piece here that's 90 degrees. So I have the 78, I've got the 194, I've got the 90. That will allow me to get the black piece. Okay, so if I just do 360 minus the whole purple piece, okay, which is 194, minus the green piece, which is 90, that will give me, that's going to be equal to, that comes out to be, yeah, 76 degrees. Okay, so the black piece is 76 degrees. Okay, now remember we're trying to find the red arc. We're trying to find the red piece. Well, I can simply add 78 plus 76. Okay, so 78 plus 76, that gives me 154. So the red piece, the red arc, is 154, and that's what I wanted to find. Remember, we're trying to find this blue angle. Okay, so all I got to do is divide that by 2 because the inscribed angle is half of the arc. So I'll just say angle TVW is equal to 1/2 of 154. And that comes out to be 77 degrees. 77 degrees. That's a tough one, guys. I'm not going to lie. That's a tough one. Okay, but if you can do that, then you've completely mastered inscribed angles. Okay, let's move on to stuff from day 4. Excuse me, this is stuff from day 3. Arcs and angles. Okay, so this is kind of tricky because you're looking at this and you say, is this the interior angle or is this the PP problem? Part times part. Well, where are the numbers? You got to look at where the numbers are. The numbers are on the arc. I see a degrees symbol. Okay, so anytime I see a degrees, we're talking about angles and arcs. We're not talking about lengths of segments. Okay, so day 3 was all about degrees, the measure of an angle, the measure of the arc. Okay, so this is, where's the vertex, guys? Where is that vertex? That vertex is inside the circle. It's not on the center of the circle. Okay, so this is your interior angle. Interior angle. You got to know this. That's equal to 1/2 of the sum of the 2 intercepted arcs. Okay, both of these problems, 15 and 16, are both interior. Look at where the vertex is. This one is the dream case. This is easy. They're trying to find x. So, actually, you know what? You know what, guys? I apologize. I highlighted the wrong angle. Sorry. Okay, so we're looking at this angle. So we're looking at these 2 intercepted arcs. We're looking at that guy, DE, and we're looking at CB, this guy down here. Okay, if the arcs are on the top and the bottom, then you're talking about the angles on the top and the bottom. If they're talking about the angle on the left and the right, you're looking at the arcs on the left and the right. Okay, so this is super easy. my angle is simply 1/2 the sum of those two guys. It's the average, okay? The average of 52 plus 56. So that comes out to be 104 degrees. 104 degrees. Okay, just remember interior angle is the average, halfway between 52 and 156. All right, this one's not so kind. Okay, so here is our angle, 59 degrees. So we're definitely looking at these two intercepted arcs. Okay, but now I'm going to show you guys, I taught my students how to do this two different ways. I'm going to show you the mathematical algebra way, and then we'll talk about the common sense logical way, which is definitely applicable to this problem. So my angle, guys, when all of these angles, interior angle, inscribed angle, exterior angle, the angle, guys, is always on the left-hand side of the equation, left-hand side, okay? Sometimes that's a number on the left, sometimes it's a variable on the left. In this case, my angle is, okay, my angle is equal to, okay, so in this case, it's a number. 59 is equal to 1/2 the sum of the two arcs. The sum of, we'll call this x. 1/2 of x plus 53. No need to distribute, guys. There's a 1/2. Let's get rid of that nasty fraction by multiplying by the reciprocal. Multiply both sides by 2. The 1/2 and the 2 go away. 2 times 59 is 118. And that will leave me with x plus 53. And then I just subtract 53 from both sides. I get x is 65 degrees. Okay. Alright, so that's pretty easy. However, I can teach you a way to do this in about 5 seconds if you know the shortcut. Okay, so interior angle is the average of 65 and 53. Well, one way to think about this is how far away is 59 from 53? It's 6 away, right? So how do we go from 59 to 53? We subtracted 6, right? So if 53 is 6 away on the low side, then the other angle has to be 6 away on the high side. So instead of subtracting 6, I just add 6. 59 plus 6 is, you guessed it, 65. So another way to think about it is 59 is the midpoint, the average, the mean of 53 and what? Okay, well 59 is halfway between 53 and 65 because they're both 6 away from each other. Just a shortcut. If you don't like that, set up your equation and solve. It's perfectly fine. Okay, those are interior angles. Okay. This video is already 30 minutes long. We're only halfway through the quiz review. I might have to break this video up into 2 sections, guys. Alright, so 17. Okay, this is another interior angle. Okay, we're talking about degrees here. Right, so my angle, the 122. Oh, and by the way, guys, on these, in case you're wondering, like on something like this, how did we know to put the x here? It doesn't matter which side because these are vertical angles. So if this is 104, this angle is 104. If this is 59 degrees, the other angle is 59 degrees. It doesn't matter, they're vertical angles. Okay, so, all right, back up top here. All right, again, so this is 122, the other side is 122. This is going to be the average of these two snow cone arcs, okay? Now this one, again, you can use the common sense. You can find the difference between 122 and 64 and then just add that to the other side, or in this case, I'll go ahead and set up the equation. My angle is equals to 1/2 the sum of that guy and that guy, x plus 64. Multiply both sides by 2, the reciprocal, get rid of that nasty fraction. 2 times 122 is 244, and that equals x plus 64. Subtract 64 from both sides, and x is equal to 180 degrees. Okay. 180 degrees. Okay. All right, so that's 17 interior angle. Number 18, where is the vertex, guys? Where is it? It is sitting outside the circle. Okay, so this is exterior, outside, all day long. Exterior angle is equal to 1/2 of the big minus the little arc. Okay, where's 1/2 of the difference? Interior angle is 1/2 the sum. Exterior angle is 1/2 the difference, but I prefer my students to remember it's 1/2 of big minus little. Okay, so here's my angle. Here's the question mark. So let's highlight that. Okay, that's in blue. Where is the big angle? Here's the big angle. It's the one that's the furthest away. It will always be the one that's the furthest away, minus the little angle, which is this guy right here. 1/2 of big minus little. Okay, so I'm going to say x is equal to, question mark, whatever. X is equal to 1/2 of big minus little. And that's going to give us 155 minus 55 is 100. Half of 100 is 50 degrees. Okay, so that's pretty easy. All right, now this one is a little bit tougher. We got to kind of go backwards here because now they actually give us the angle. And once again, how can I tell the difference between PP, wee wee, and wet? Okay, how do you know this is not wet? Because I see degrees. Okay, measure of an angle, measure of an arc. Okay, so we're not doing the wee wee whole times exterior here. All right, so where are my intercepted arcs? I've got this guy in green, and I've got this guy here. Okay, so we'll call this is our x. All right, so when I set up my equation, I say my angle, my exterior angle, is equal to the big arc, 1/2 of the big arc minus the little arc, 1/2 of 180 minus x. Multiply both sides by 2, and we get 116, those cancel, is equal to 180 minus x. If you want to keep a positive variable, we can add x to both sides. I get x plus 116 equals 180. Subtract 116 from both sides, and we get x is 64 degrees. Okay, number 20. This one's a little tough here. This one is a challenging problem. If you can do this one, you've definitely mastered exterior angles. Okay, so there's my angle. That's going to be equal to 1/2 of big minus little. Okay, wow. Well, they didn't give us anything. They gave us jack diddly squat. I don't have either big or the little angle. Okay, well, let's call this x. Okay, if the green arc is x, this is the scenario, guys, where when you have two tangents, what can you tell me about the green arc and the red arc? What do they form? Ah, they form a circle. So if the green arc is x, what would the red arc have to be? 360 minus x. Okay, let that sink in for a second. This guy is x. The red piece has to be 360 minus the green piece. 360 minus x. Now I can set up my equation. Okay, my angle, in this case it's a number, my angle is equal to 1/2 of the big arc, which is x, minus the little arc. And here's where everybody makes a mistake. You got to subtract this whole expression, guys. We're subtracting the whole thing, okay? So you got to put a parentheses here, 360 minus x, double parentheses. And guess what you got to do? You got to distribute. 63 equals 1/2 of x. That's going to be negative 360. Negative times a negative, that's going to make that a positive x, okay? If you didn't do that, you would have x minus x, and they would cancel, and you just have an equation that doesn't work. Okay, so now I combine my like terms. X plus x is 2x minus 360. Now I'm ready to double both sides. Let's get rid of that nasty fraction. They cancel. 2 times 63 is 126. That equals 2x minus 360. And let's add 360 to both sides. So I have 2x is equal to 486. I'm going to divide by 2, and we get x is 243 degrees. Okay, that's a tough problem, guys. That's a tough one. That might be something like a bonus problem, maybe. Okay, Number 21, and guys, the bell is going to ring here in about 2 minutes. So now we're getting into all the pee-pee wee-wee wet stuff. You'll notice we don't have any degrees here, no measures of angles, everything is numbers, links, okay? I'm going to stop the video here and I will finish the second part of the quiz review probably after school, and I'll upload both parts to my website. Hope you enjoyed this, and I wish you good luck. Please, please, I'm begging you guys to study. Study like you've never studied in math, and you will be set up for success on your quiz. I'll see you on part 2.